we're finishing off the problem about human pregnancies. So in part D, we want the probability that a random sample of 50 pregnancies has a mean gestation period of 260 days or less. So again, if we draw our picture, we have the mean of the sampling distribution, which is 266. Our standard error of the mean is this time 16 over the square root of 50. And we need the probability that it's less than 260 days again. So, as we've been doing, the probability that the sample mean is less than 260 days is normal CDF, negative 999,999 for the lower bound, 260 for the upper bound, 266 for the mean, and 16 over square root of 50 where the standard deviation goes. And that gives us a probability of 0.0040. So what might we conclude if a random sample of 50 pregnancies has a mean gestation period of 260 days or less? Well, since that probability is less than 0.05, the probability is unusual, right? Remember, anything with a probability of less than 0.05 is unusual. So what does that mean? That means we might conclude that the sample that the sample came from a population whose mean pregnancy length is actually less than 266 days. Okay, what's the probability that a random sample of size 25 will have a mean gestation period within 10 days of the mean? So first of all, what does within 10 days of the mean mean? What are they really saying here? Well, let's draw our picture as always. So the sampling distribution mean is 266, and we want within 10 days. So that means 10 days to this side or 10 days to that side. So 10 days below to 10 days above. Well, 10 days below 266 is 256, and 10 days above that is 276. So we need to find the probability of the sample mean being between those two numbers. And remember, our standard error is the standard deviation of the population divided by the square root of the sample size. So that means the probability that the sample mean is between 256 and 276 is our normal CDF. Lower boundary is 256. Upper boundary is 276. The mean is 266. And where we put the standard deviation, it's 16 over square root of 25. When we put that in the calculator, we get a probability of 0.9982. All right, the last one on our pregnancy problem. There is a 20% chance that not a pregnancy problem. Well, that should not say mean reading rate. That should say mean gestation time of a sample of 20 pregnancies will exceed how many days? So we know the mean for the sampling distributions in the middle. We want to know what the X bar is so that the area to the right is 0.20. How do we know it's to the right? Because it says exceed, and exceed means greater than. So if the area to the right is 0.20, what is the area to the left? Remember, we always need to give the calculator area to the left. So that's 1 minus 0.20 or 0.80. Again, our standard error is standard deviation of the population divided by the square root of the sample size. So this time, the unknown value of X bar we're looking for is the inverse norm of the area to the left, which is 0.80, the mean, and the standard deviation, which in this case is the standard error of the mean. And when we put that in, we get 268.69 days. So if we want to round, 269 days is the cutoff between the shortest 80% of pregnancies and the longest 20%. That concludes the videos for section 8.1. We'll pick up again in section 9.1.